All right. Good evening, students. Good evening, everyone.
Even
Evening. Come on. All right, guys. I am seeing some names in the chat that I am not 100% familiar with, or I'm not even sure though. Do we have do we have any new students joining the class? Is there anyone that's new? Shanae Hendricks. I'm not sure if I know that name. Shanae, you new?
No, sir, I'm not new. I've been here from the class started.
Okay, because children don't really know the names them and the voices. So there's nobody new. All right, cool. All right, so pleasant evening to everybody. We're just gonna take about 5 minutes to just get your feedback on what was the assessment like. Before I take some feedbacks, I posted the results. I posted the explanation and the solution on my channel about 20 minutes ago. So I guess you can watch it at a time convenient to you. So it's currently live right now. Obviously you can't watch it because you're in class now, but once you've gotten back your results, right? Even if you don't get back your results, I think you guys know what you did. And I think you guys still have your physical paper. So you can go ahead and watch that and, of course, make the necessary corrections. Not to hand to me, but make the necessary corrections that when you see these things pop up again now and in the future, you'll know where you went wrong and you'll know how to approach the question the next time. Come on, if you can do me a favor, just in case anybody don't know where my channel or what my channel name is, if you can copy the link from YouTube, whether it's the recent video or just the channel link, and post it in the chat. Thank you very much. All right, so stay tuned for that, ladies and gentlemen. All right, so feedback. Was the test challenging? Can I just throw it out there? Was the test challenging?
Sir, I only found one to two questions challenging because I didn't remember.
Understood. And I appreciate you not using AI to help yourself. All right. I hear, sir. Talk to me.
It's me, sir. Listen, it was a challenging. It was, but the problem is this, right? While you're having class, I'm able to talk and say yes, and I know exactly what to do. But you see, with maths and tests, it's like I have this phobia, right? And then you even said that you're going to send the Holy Spirit or whatever, so we should not cheat or whatever. Try to obey, right? And try to get it done. But it's like I know exactly what to do, but anytime I have maths on a paper, like a test, it's like, I don't know, I panic. I know what to do, but then I don't know what to do.
I get you. A lot of my students in the past, present, and I know in the future, they're struggling with recollecting the information under pressure. So that's something that I don't really have a cure for it. I think it's just something that people have to just deal with. And over time, as you become more successful with your attempts at assessment, the more successful you are, the more the fear will go away. But I mean, hopefully the approach that I'm taking towards teaching you and the consistent assessment you're getting, hopefully, over time you'll gain some confidence in just do what you know. I think you're afraid of getting things incorrect, and you can't be afraid of getting it incorrect. You need to just get it incorrect so say, all right, then guess what? The next time you try it that way, you know what will happen. So, I appreciate all of you guys who attempted the test and you did not, cheat yourself. You can't cheat me, but you didn't cheat yourself. So I appreciate that. Anybody else has an opinion that they want to throw out there? Leon, how was the test?
Sir, to be honest,
doable? Not doable?
One question, because I didn't remember what to do, but the rest was kind of easy. Not easy, but I followed
not very good.
I remember.
Kian, how was the test? How was the assessment? She probably is not near the phone. Anybody else want to like throw something out there? What did you experience like while you were doing the assessment? Apart from what Miss Barrett said a while ago about can't recollecting the information, what else did you experience? Was the case where like you couldn't find the functions on the calculator? What go on?
Yeah, for me, fear for math as well, but at one point for the cube root,
couldn't find the button.
That was an issue. I had to use my phone because I'm not sure if the calculator that I have is programmed as yet because it is new.
Okay.
But I eventually got that. And as for, I think, the 2 back questions, I think I needed more practice for that one.
Understood.
Yeah.
Okay. I appreciate you.
I think I'm able to overcome my fears.
Yeah, man, with time and maturity, a little bit more success. All right. But yeah, man. So I don't know your test results as yet, so I can't really say. I sent some information in the group, but it was just based on everybody else who attended the assessment. So it wasn't based on your results, okay? But I got some passes. I got about 20 persons or close to 20 persons passing my pass mark. So let's see what your results are like. I will be marking your paper and then emailing back your results to you. You're gonna see the ticky. It's gonna take a little while, guys. But I'm gonna email it back to you so you can see what your results are. And as I said, for those who did not get a chance to attempt it because you either did just start or you were missing in action, and even those who attempted the test, give it a chance. Give it a chance to do the paper, because I'm gonna send the results in the group. Do the paper, and then what you do is go online and you watch the video, and then you look at what I did compared to what you did, and then you can see where you go wrong. Remember, students, in order for you to improve, you have to be very objective about your learning. You can't be emotional. So you can't set yourself a target and because you didn't get it, you want to give up. You can't. You need to find out where you're falling short, and then you'll be like, okay, so that's what I did, or that's what I should have done, or that's what I didn't do. And then so the next time you see these type of questions, now you're going to approach it in that particular manner. But all right, look out for your results. As soon as I finish marking everybody paper, I'll hint you in the group to check your email, and you'll get back your results. But we have to move on, guys. We can't stay at the fundamental stage of maths. We have to move on because we are prepared for exam in May. So I'm going to be going.
Sir,
yeah, go ahead. Yeah,
so
go ahead.
We should go and pay the money.
I mean, I can't remember, guys. I only said that I'm going to recommend that, because I can't really stop the adults from doing it. I mean, you as the adult need to say to yourself, am I ready? Let me do one more assessment. So your next assessment is in 3 weeks. Do one more assessment before you pay your money. And then you will then convince yourself that, you know what, I'm really going to try this, or, next year. But I would encourage everybody to give it a try. Try. Right, yeah, whether you have the money or once you have the money to pay for it, try. And at least at the end of the day, you can either get some experience and you come back again, which as Mr. I think nobody will come back again. Because I don't want to go pass for me to teach you. But give it a try. I feel like you should give it a try, guys. Okay? Yeah, go ahead.
Yes, Miss
Sherry, go ahead.
Oh, I didn't get to attempt the test.
I realized because I didn't get an email from you, so I realized.
I want to attempt it.
Well, you can't attempt the test because the test is null and void, but you can do the paper, and then once you've done the paper, then you can go online and watch the solution to see what you did versus what should have been done. But me marking the paper is null and void because I've already released the results.
Oh.
But you can do it on your own and then check the results online to see where you went wrong or right.
So how could I get the paper?
I'm going to send it in the group.
Pardon?
I'm going to send the document in the group.
Okay. Thanks.
All right. So
Excuse me,
we'll get
sir.
that out of the way, guys. A question?
Yes, sir.
Go ahead.
You said the exam is in May.
Of next year, yeah.
What about the person that are doing it in January?
Oh, this is not a resit group. I think what the school informed you is that you're going to be in this class until about December, where you're going to experience some of the topics then, but this is not a resit class. This is a class that is preparing students for next year, May. But a lot of the topics that we're teaching now are going to be topics that you're going to be seeing on your exam. But you won't get all the preparation, not in this class at least. We don't have a resit cohort.
Okay, sir.
All right,
Thank
good. Yeah, you're welcome. All right. What's the name of the young lady that was talking to me a while ago?
Me, sir?
That was just asking about the resit.
Oh, never heard this one.
Okay, so I do have some videos on my channel that allows you to, like, I've done some past papers, 2024, 2023, 2022, 2019. Hit me up in my DM on WhatsApp and I'll send you those specific links. Those can help you to prepare even more for the actual exam in January.
Okay, sir. Thank you.
You're most welcome. All right, guys. So we have to move on. So I'm changing the teaching strategy a little bit. We are now going to have a particular topic that I do on a Monday. Pardon me, not Monday, mixing it up. So I'm going to have a particular topic that I do on a Tuesday. And then once wherever we stop on a Tuesday evening, we don't return to that topic until the following Tuesday. Then I'm going to have a topic that I do on a Thursday. And wherever we stop on that Thursday, we don't return to that topic until the following Thursday. So we're doing 2 topics per week. That's my teaching strategy that I've been using for a couple of years now, and it has been successful. Right? To an extent. Because we have a lot, and I can't stay on one topic for too long. All right? So we have to bounce from one to the next. All right? So that's the strategy, guys. So for tonight, we're going to be doing the topic measurement. Okay? Measurement is what we're going to be doing tonight. So head up that for me, guys. We're going to take some notes. We're going to go through the whole, rigmaroles of what a measurement is, the topic, what the entire discussion is going to be about. So the topic for tonight, guys, is measurement. And on Tuesday, we're going to be doing algebra. So algebra on Tuesdays and measurement on Wednesdays. All right? So make a note of that for me. All right, ladies and gentlemen. So the topic of measurement. What is this topic all about? Starting fresh. So all my new students, resit, everybody. It's a fresh topic. It has nothing to do with what we have done already. So we're going to start fresh. Now, this is the first topic on the math curriculum where you're going to be exposed to a wide range of formulas. And for those who have ever done CSEC before, you would have been exposed to a CSEC paper where they give you some useful. So them say the formulas are useful at the front of the paper. You and I both know that those formulas are not very useful to a lot of the questions that they send come on the paper. However, majority of the formulas sent by CXC are formulas that are under the topic of measurement and also a few algebra formulas, but that's just about it. Somebody's trying to get into the meeting. Hold on. Give me a second, guys. I don't want you guys to start the late, It breaks the focus of the class, but all right, let's see. All right, ladies and gentlemen. So for the topic of measurement, we're going to be focusing on two particular areas, right? So we're going to be focusing on area of two-dimensional shapes. We're going to be focusing also on perimeter of two-dimensional shapes. And once we have grasped the concept of areas of shapes and perimeters of shapes, we're then going to use that knowledge and move on to what is known as the volume of three-dimensional prisms. We're going to be breaking everything down. What is an area? What is a perimeter? What are the different shapes? What are the properties of the shapes? What are the different formulas? Which formula you must study? Which one you're not supposed to study? Which one CXC help you with? Which one CXC doesn't help you with? We're going to be breaking it down. We're going to be taking our time. We're going to be doing applied questions. I'm not going to just teach you the basic form and then leave it up to you to practice on your own. We're going to be doing a wide range of thinking questions. All right? So stay tuned. Are you guys seeing my screen? I'm so sorry. Like it disappeared.
No, sir.
My screen has disappeared? Okay. I think it's supposed to be back right now. All right, so it's back. All right, so let's get into that now, guys. Let's get into that. So take this down for me, guys. We're going to start off the whole entire measurement topic with the concept pardon me?
Excuse me, can you let me in? I'm joining my computer. I'm going to leave with my phone.
No? No? You should be in by now. All right, guys. I'm not letting anybody else in. That's it. All right, guys. Write this down for me, ladies and gentlemen. An area, we're going to be dictating, guys. An area is the total surface covered. An area is the total surface covered by a two-dimensional shape. By a two-dimensional shape. An area is the total surface covered by a two-dimensional shape. Full stop. Now, for some of you, you guys have not, or you're not familiar with what we as mathematicians call two-dimensional shapes. At least you're not familiar with it, with that terminology, but you know what they are, right? And we're going to start them off. We're going to start it off by listing the common two-dimensional shapes. Square, rectangle, triangles. I have to pluralize that one because there's more than one of them. So square, rectangle, triangles, circle. Parallelogram. Trapezium. And I believe that's it. That's about 6 of them. So 1, 2, 3, 4, 5, 6. 6 of those. Those are the 6 main two-dimensional figures that you most likely will encounter on a CXC paper or during your practicing. So square, rectangle, triangles, circle, parallelogram, trapezium. Now, some of you guys are familiar with what is known as the kite and the rhombus. Those are all, they are also shapes, but we don't really talk about them a lot at this level, right? Because a kite is very similar to a square. What makes a kite is the orientation. I changed the orientation of the square. And a rhombus is very similar to a rectangle. I just changed the orientation of the rectangle and we will get a rhombus. But we're not going to talk about kite and rhombus. We're going to focus on the 6 main two-dimensional shapes. Now I'm going to be sketching them, right? I'm going to be sketching them as well as we're going to be discussing some properties, some things that we need to know about them. Because if we don't know these properties, then later on when we're ready to do the application question, then we're going to have some issues. So we don't want to have no issues. We want to clear those out of the way first, and then we can dive right on in. All right, so let us start off with the square then. So I'm assuming that almost everybody here is familiar that a square looks something like this, right? And so for a square, one of the main property of a square is that all 4 sides measure the exact same measurement. Well, they have the same exact measurement. And we also know that with a square, each of the corners of the square measures exactly 90 degrees. With a square, we do not distinguish the sides because all the sides are equal. If I decide to call one side L, then every side is L. That's my L, guys. That's how I write my L. So it's not an E. Don't get it confused, okay? It is an L. So if I call one side L, it means all the sides are L. And when we talk about area, for those who don't know, when we talk about area, ladies and gentlemen, what we're talking about, what the examiner is asking you to do is the examiner is asking you to find how large is this surface that is bounded by the sides. In here, so I'm gonna ask it for. So we want to know how large is this section, right? In here, so. So that's what we refer to as the area. It's the region bounded by the 4 sides or the 5 sides or whatever sides, however many sides the shape has. Now, for the square, we have a formula. And with the formula, it stays constant. All right? It stays constant in terms of there's no deviation, there's no changing in the letters. The formula is just the formula. It was designed that way. So for the square, we use the letter A to represent area. And so for the square, the area is said to be equal to length multiplied, let me just write that a little better. So the area is said to be length multiplied by length. In maths, we like to use letters to represent. So we just say A is equal to length multiplied by length. Or as the high school students, they'll say side by side. So area is equal to length by length or side by side. We like to keep things simplified. In mathematics, the simpler the formula is the better for us. So a better way of writing L times L is to say A is equal to L squared. I'm going to put a little red box around this because I want you to use this one as opposed to the other one. So this is the formula we're going to be working with in the future, guys. That's the formula we're going to be working with. A is equal to L squared. Don't use L times L, guys. Use L squared. And as we go through the course, you will realize why I'm telling you to use L squared as opposed to L times L, right? So you'll see in a second. Now, the next thing that we want to look at also is something known as the perimeter. And so when we talk about perimeter, ladies and gentlemen, what we're talking about is the distance around the shape. So we want to know what is this length plus this length plus this length plus this length. We want to know the distance right around the edge. Now, the letter P is what we use to represent perimeter. So perimeter is equal to L plus L plus L plus L. Now in math, as I said, we like to keep things simple. So the simpler we can make it be, is the better. So P is equal to, there are 4 L's, so we just take one of the length and multiply it by 4. And so this becomes my perimeter formula for a square. So 2 formulas we learned already. A is equal to L squared, and P is equal to 4 multiplied by L. All right? Everybody with me so far?
Yes, sir.
You need to make a note of this. Remember that some of the formulas appear on the exam paper, while some don't. Just a second, guys. I think somebody... check something. He's not in the room, so I don't know. Anyways. That's what we're working with so far, guys. All right. So A is equal to length times length, or length squared. P is equal to 4 multiplied by L. Now, when it comes to area is measured in what is called squared units. So let me just write that down.
Sir, you said P is equal to 4 multiplied by L.
That is correct.
We have 4L. The one in the box you're talking?
Yeah, so 4L means 4 multiplied by L.
Okay.
Yeah. So now, area is measured in what is called squared units. So we write SQ units. And what squared units mean is that if the measurement is given in centimeter, then when you find the area, it's going to be in centimeter squared. If the measurement was given in meter, then it's going to be measured meter squared or squared meters. So in other words, then once you're given the dimensions of that particular shape, then the area is going to be squared, whatever that unit of measurement is. So centimeter squared, meter squared, kilometer squared, squared units. However, with perimeter, which is a distance, there is no square on it. So for perimeter, if the dimension was given in centimeter, then your answer is going to just be centimeter. So area is the only one that contains squared units.
Sir, what's that word?
Okay?
SQ
Squared units. SQ, full stop, UNITS. So it's squared units. All right. So we need to do an applied question then. Because we take it slow, we're not rushing. All right. But remember, guys, it's going to be very important. Even for my older students, students who haven't done math in a while, you have to find one way to get it up here. It has to go up there. Because you forget the formula, you can't apply it. You can't get the answer to the question. You have to know your formula. Now, there are some formulas that I'm not going to really kind of pressure you to remember because CSEC does provide them to you. But there are going to be some that we don't have a choice. If you don't know it, you can't solve the problem. Here's my first square. All right. And I'm going to state here that this particular square, hold on. Okay. So this particular square, it has a side measurement or a length measurement of 4.3 centimeter. And I can confirm that this is a square because I have 4 right angles in the corner here. And they can only ask you one of two questions, ladies and gentlemen. They can ask you to find the area of the shape. Let's label the shape because they like to label it. They like to say this is A, this is B, this is C, and this is D. So they'll say find the area of A, B, C, D. And they'll give you 2 marks or 1 mark, whatever the case is. And then they'll go to part 2 now and they'll say find the perimeter forgive me for the handwriting, guys. I'm not using the pen. The pen, the sensitivity on the tablet is not, it's not cohesive with the pen that I have. So I'm using my fingers to write. Okay. So that's why most of the time when I'm writing, I'm always talking. So you guys will understand what I'm writing down. So I'm going to try my best. So find the perimeter of, once again, A, B, C, D. Now with a question like this, you need a formula, right? I always encourage my students that regardless of whether or not you know the formula, in your head mentally, practice to write down your formula. So you start your question by always saying A is equal to length squared. Do not use L times L. If you use L times L, you're still going to get the answer now. But use L squared, guys. Just please use L squared. So therefore, then A is equal to 4.3. Put no one bracket and square it. And of course, because we've gone through the fundamental aspects of math, by now, everybody is supposed to have a calculator and they should know where their square button is. That's the one. That's the button that says x to the 2. That's your square button. If you still can't find it for whatever reason, then 4 squared actually means 4.3 multiplied by 4.3. Can somebody confirm what that answer is, please?
18.49.
18.49. So some students will ask me, or some students have already asked me, sir, when I'm doing questions like this, do I write 2 decimal places? Do I write 1? If you're not instructed, write it to 1. If you're instructed, then follow the instruction. But for me, 18.49, or if you want to round it off, you can just say 18.5. What am I missing? What would allow Mr. P to take off half mark off your paper? What am I missing?
Centimeter squared.
Very good. That's how brutal I am. You leave off the centimeter squared, I am taking off half marks. I promise you. Sir, you're too harsh. All right, that's how you go. We all can't be nice. I'm not nice when it comes to leaving off my unit of measurement. Okay? And that is your answer, guys. So basically what we're saying is that the size of inside here measures 18.49. Proceeding to this next question then, we're looking at finding the perimeter of ABCD. So I want to know the distance around here. This plus this plus this plus this. So we're going to write P, start with a formula, guys. Please start with a formula. P is equal to, if you want to write L plus L plus L plus L, have fun. That is a lot of work. So I'm just gonna write 4L. And I know that 4L means 4 multiplied by L. So P is then equal to 4 multiplied by the 4.3. And what am I getting?
$17.2 centimeters squared.
17.2 centimeter. Not squared, centimeter. Area is the only one that has the squared units. Distance, meaning perimeter, doesn't. Is it clear, ladies and gentlemen?
Yes, sir.
Everybody up? Miss Cherry?
1 minute, sir.
Not really, sir. I was
Not really
trying
with
to
what?
talk.
Where have I lost you? What did I do that you did not see?
When you're finding the perimeter, you're gonna multiply the area. The area.
The perimeter has nothing to do with the area. I just take the side and I multiply it by 4 because a square has 4 sides.
Oh.
So I take the distance, which is 4.3, which is up here. And because there's 4 of them, as opposed to saying 4.3 plus 4.3 plus 4.3 plus 4.3, we just say 4.3 times 4.
Okay. Okay, sir.
Is that it?
Yes, sir.
Okay. All right, boom. So we get that out of the way. Let's look then at the rectangle. So make sure you get the formulas in your head. And every class, guys, you need to ensure that you try to get those formulas up here. You have to try to remember them, guys. Every year we teach maths, every year people struggle with this topic. Them can't remember the formula. Why? Sir, I'm not practicing. I can't hold so much formulas in my head. How I did it? I did it. So you can do it as well. But you have to take the time out to get it up here. Boom. So here's my rectangle now. And with the rectangle is a more elongated shape. Hold on, let me see if we can draw one prettier rectangle. Hold on. That one they look a bit better. I like how it look. Hold on. Alright, that's the best we can draw it for now. So that's my rectangle. The gray area represents the area. And so, of course, I'm going to take 4 right angles and put them in the corner. And I'm going to give the sides a measurement. So I'm going to say that this is, I'm going to call this short side here. In fact, hold on, we're not naming it. So we have 2 long sides and we have 2 short sides. Now the examiner likes to use these little indicators here. He likes to put a double stroke. So he or she likes to do this. What the examiner is trying to communicate with you is that the examiner is trying to tell you that the sides that have the single stroke are equal, and the sides that have the double stroke are exactly the same measurement. So therefore then, with a rectangle, unlike the square, we have to distinguish between the length and the width, because the length is the long side and the width is the short side. Bear in mind that the width can also be longer than the length, and the length can also be longer than the width as well. So any side can be the length, any side can be the width.
Stop sharing.
I know. I just realized. So in this case then, right, I'm going to say that this is my length and this is my width. And I use L to represent length and I use width, W to represent width. So I can therefore design some formulas now. I can say area. Let me write that a little bit better. Is equal to length multiplied by width. And in math, of course, by now you realize that we like to keep things simple. So we just say A is equal to LW. LW means L multiplied by W. Miss Cherry, you understand that? LW means L multiplied by W. So then if I decide to use this diagram here, and let me just draw a different one. That's my rectangle, not the perfect one, but you know what I mean. And if I decide to say that this side is 7.3, centimeter, and the short side is say 2.4 centimeter, they can ask me one of two things. At the level that we're at, they can ask me one of two things. They can either say, one, determine the area of, and they love to label it. So they like to say P, Q, R, S. So area of P, Q, R, S. And they will also ask you then for part 2, they'll ask you to calculate the perimeter of PQRS. Now, for question number 1, determine the area of PQRS. We can confirm that it is a rectangle. Can anybody tell me how you know it's a rectangle from when it's a square? How do we know this? How do we know if it's a rectangle versus a
You
square?
have 2 short side and 2 long side.
All right. Talk to me. How can I confirm? Miss Cherry said 2 long side, 2 short side. That's okay. Me work with that. But what else can I look at to confirm? Like me sure, 100% sure, say the teacher can't trick me. How do I know it's a rectangle? Come guys, work with me now, man. Entertain me in the class now.
The shape.
The shape,
What
yeah,
Miss
but me can
Cherry
I
said, sir.
can draw one square until it's a rectangle. Not true?
The stroke.
The stroke, that too, that can, yeah, I know, just come off. I know that can work too, but we need something else. There's something more you say.
The measurement on it, sir.
That more here. It is the measurement. It is the measurement that is on the diagram that allows you to determine whether it's a. So you see the mere fact that the measurements are different, that confirm that it's a rectangle. So thank you very much for that. So therefore we can say that area is equal to length multiplied by width. So the length, does it matter what I call the length or the width? I mean, most persons always associate length with being long. So most persons are going to call the length 7.3 and they're going to call the width 2.4. But it can be the other way around. No? The width can be 7.3 no? And the length can be 2.4. So in this case then, 7.3 multiplied by 2.4. Somebody confirm that for me, please.
17.52.
17.52. So that's 17.5.
How you get it on the calculator, sir?
Yeah, Miss Cherry, no, sir. You have to type in that, Miss Cherry. You must can type in 7.3 times 2.4.
Oh, me think you go for the scientific part.
No, man. We're not doing
No.
scientific. Just basically multiply with this and multiply.
Okay.
Basic multiplication.
Okay.
And what is missing?
Unit, sir.
CM.
CM squared. Thank you. Square by cube.
Square.
Sorry, sir.
Okay. All right then. For the perimeter now, we're going to slide it over here. So the perimeter now is, we never even discuss it, but we're going to discuss it now. The perimeter means distance around, right? So it is safe to say that we can say that P, let's design a formula for perimeter. So P is equal to length plus width plus the length again plus the width. Do we agree? So the long side plus the long side plus the short side plus the long side again and the short side. Not true?
Yes.
Now we can start this now. We can fix it up. We can say P is equal to, how many L's are there?
2.
So we can just say, simplify it and write 2L. And how many W's are there?
2. 2, sir.
Oh, that's 2W. So that's a simplified formula. Now remember guys, there's a lot of persons that don't like formulas. And there's a lot of persons that like common sense. So basically then is, if you can common sense out the question and just tell yourself, Miss Cherry, say, you know what, anytime you find perimeter, I just add up all the sides there, no problem. Just add them up, go on with your show. But for some students, if you don't give them a formula, them can't work out the maths. Them can't work out the maths. So if you guys want a formula, that's one for you. That's one for the books. So let's go ahead and use that formula then. P is equal to 2 multiplied by, what is the length? What did we choose as the length?
7.3 centimeters.
And What is the width?
2.4 centimeters.
So let's go on the calculator. So 2.2 times 7.3 is going to be 14.6. Can we confirm?
Yes, sir.
Yes, sir.
Yes, sir. Sir, the answer
And
is 19.4.
Oh, the whole answer you're giving me? Hold on. Take time with me. Hold on. 2 times 2.4 is, inside the whole class we are teaching, so we don't want to run left somebody. So 2 times 2.4 is going to be 4.8. And when we add up that, what we get?
19.4.
19 point. Listen, 19.4. Okay, 19.4 centimeter. All right, just to make it more simple, just say 7.3 plus 2.4 plus 7.3 plus 2.4. I kind of feel like that is, too much. Just multiply 2 times the length and 2 times the width. And that's how we find the perimeter. Okay? Is everybody clear?
Yes, sir.
Yes, sir.
No. All right, now, why am I emphasizing so much on writing down the formula? Because when you get the question, ladies and gentlemen, most times when students are being taught, I observe a lot of teachers when they're teaching. Them teach in a very straight line. And they make it seem whenever they're, and I'm not discrediting other teachers, I'm just saying that a lot of teachers, when they're teaching, they teach in such a straight line that they make the students feel as if a one way the question I go ask. Like they'll ask, most teachers will make you feel like, oh, every time you get an area question, they're going to ask you to find the area. But I can give you a question and I can tell you what the area is, and then I can ask you to find what was the length that gave me that area. So watch this now. I'm going to draw one diagram. That's my square. Not true? That's my square. It's not a perfect square, but that's my square. Okay? And I'm going to write inside here. I'm going to put 74.5. Let me just write it a bit smaller. 74.5 centimeters squared. So when I put that number inside there, I'm trying to say that the measurement inside is 74.5 square centimeters. And in the instruction, I will say to you that all four sides are equal. So let's label it. Let's call this square, let's call it W X Y Z. And in information, I will say to you that W X, whoops, wait, gone. Okay, so in information, I will say to you that WXYZ is a square. And what CXC loves to do is not just CXC, it's just in general. An examiner, what we like to do is that we like to create a story around the diagram. So as opposed to telling you that it's a square, I can say to you that WXYZ, or I could say to you like, I could say that a man has a garden that is in the shape of a square. So I'm creating a story so I can make the math more realistic. So a man has a garden that is in the shape of a square. And his garden has an area of 74.5 square centimeter. You guys want to write that down? Write that down for me, guys. Write that down. A man has a garden that is in the shape of a square. And it has an area of 74.5 square centimeters. Full stop. Calculate the length.
Excuse me, repeat the question, please.
A man has a garden that is in the shape of a square. And it has an area of 74.5 square centimeters. Calculate the length of one edge of the garden. Calculate the length of one edge of the garden. Calculate the length of one edge of the garden. So I've created a story around the question by telling you about the man's garden.
Sir,
Yes, go ahead.
you're going to divide by 4 to get the 1.
All right. So I'm going to allow you to tell me what you think we should do, and then we're going to examine if it's right or not. All right. So you're suggesting that we divide it by 4?
Yeah, to get the 1.
All right. Let us test it then. Right. I like when my students tell me what they think, and then, allow you to do it, and then let's see what happens. So what's your name there? I don't get used to all the voices. Run your name by me again.
It's Danica.
Oh, Danica. Oh, Danica, I need to get used to your voice. All right, Danica. So you're suggesting that we're going to take the 74.5, that's your suggestion, and divide it by 4. So that means, let's go ahead. Divide that by 4 and tell me what you get.
$18.625.
Pardon me?
18.65.
All right, so we're going to just use 18.6. So Danica is suggesting that this could possibly be 18.6. And because it's a square, we know say all the sides are equal. So every side would be 18.6. All right, so Danica, so all right, let's take that suggestion into consideration, 18.6. Now it simply means then, Danica, that if I take this, because remember, the area of a square, we can prove it, So if one side is 18.6, then that means if I take 18.6 and I multiply it back by 18.6, I'm supposed to get 74.5. If I'm not getting that, then it means that that approach is incorrect. Did you get back 74.5?
Sir, I got 74.4.
When you multiplied it by itself?
No, I multiplied it by 2.
Oh, no, man, we don't want to multiply it by 2. Because remember, Danica divided 74.5 by 4 because she assumes that all 4 sides would measure 18.6. But remember that the area of a square is length times length. So if you multiply 18.6 by 18.6, if you're not getting 74.5, it means that that approach is incorrect. Are we getting it?
345.96.
So that means there's something wrong, Danica. All right, so let me just explain to you what is incorrect there. Okay?
Wait. You want to tell how it go first?
I don't hear you.
I would like to tell you how it's supposed to go.
All right, no problem.
What's your name again?
Danica.
Square. No, Roxanne.
Oh, you're Roxanne. Okay, go ahead, Roxanne.
I think it's square root.
It is square root. But how the students them are gonna know? Because you have to tell them, oh, you know, say a square root in Danica. Roxanne. What did you do? What was your layout?
Okay. So the area is because it's a square, it's length times length. So
we don't want to use length times length, we're gonna use L squared.
Okay. L
All right,
squared.
good.
And in order to find how what the length, what the measurement, you have to you know.
May I hear you say you have to what? You have to what?
You have to take the square root. I can't explain. I don't know what to do.
You have to take the square root.
Yes.
Let me articulate it a little bit better for you students. What Roxanne is trying to say is, every time you get a measurement question, remember guys, the number one rule is to start off with writing down your formula. Always write down the formula, guys. You'll hear me say this to you 77 times 7. Always write down your formula. Now, since as we are told that the area, somebody's mic is unmuted. Since as we are told that the area is 74.5, Danica, then we're going to take the 74.5 and we're going to put it underneath the respective letter that represents area. So we put the 74.5 underneath the A. And we're going to follow the formula, what the formula tells us. So it's a equal, that means 74.5 is equal. We're looking for the length, so obviously the length is unknown. Now you would have been exposed to a little bit of doing the opposite to get what you want. So the opposite of adding is to subtract, and the opposite of subtracting is to add. Which means that the opposite of divide is to multiply, and the opposite of multiply is to divide. Are we in agreement? Is everybody in agreement with that statement? Everybody's in agreement with that statement?
Yes, sir.
Yes, sir.
Yes, sir.
So what we don't know is, what is the opposite of squaring? Because I haven't taught you that yet. So now you're going to be learning that the opposite of squaring something is to square root it. That means as multiplication is to division and addition is to subtraction, then squaring is to square rooting. So that means then we have to use the opposite operation to isolate the unknown variable. Isolate means to get the unknown variable by itself. So that means since I want L, then it means that I'm going to have to take the square root of 74.5, and that will produce the result of L. So therefore, go ahead and find your square root button. We've spoken about this when we were doing decimals, so I don't think anybody have any problem in finding that symbol on your calculator or on your phone.
There's 8.63.
8.63, so we're going to keep it at 8.6 centimeter. Now, I don't think we need to prove it, but you know, we're going to test it out. So we have 8.6 and 8.6. So if we were to multiply 8.6 by 8.6, we're going to get an approximate answer. We're not going to get back the 74.5 because the 8.6 was rounded off. All right, the 8.6 was rounded off. So if you multiply 8.6 by 8.6, you're going to get an answer very close to 74.5. Confirm with me what you guys get.
73.9.
And if you round that off, you see you get 74. So it's going to be close because we rounded it off. We rounded out the 3 decimal places. All right? Noted?
Yes, sir.
All right, good. So Danica, you get it clear now, love? Done?
Yes, sir.
All right, dope. Good. So going forward, guys, that is how you approach the question. Now the question could go further, and then it says after finding the length, they can therefore ask you to find the perimeter. So once we find the length, now we know we don't have any more problems because the length, the perimeter would just be 8.6 multiplied by 4. Now Danica, you can multiply it by 4 because I add up. So 8.6 plus 8.6 plus 8.6 plus 8.6, which is 8.6 times 4, which is how much, guys? Talk to me. So like about 26.4. Confirm. No, wait. 4 times 8 is 32. So like 34.4.
4.4.
34.4 centimeter. All right? So you have to look out for these reverse questions. They love to ask you questions in reverse. They like to give you the area and ask you for the length or the width. Okay? Are we in agreement? Everybody's up? Everybody's okay?
Yes, sir.
All right.
Sir, can I go back to the slide? I want to screenshot it.
Oh, okay. There it is.
Okay, sir.
All right. Here's a very similar question now. I don't want to rush the question. I want to just understand the thought process. Because a lot of students that I've taught over the years, they struggle with this aspect of the math, the reasoning part. If I don't ask them to find the area, the math can't do. At least that's what them say. So that's another rectangle, right? And this time I'm going to write inside here that A is equal to 110 just 110 square centimeters. All right, I'm going to put an X right here, so just a letter, just a random letter, X. And I'm going to put 14.3 down here, so. And I'm not going to create a story around it. I'm just going to draw the diagram. I'm going to label the diagram. I'm going to call the diagram, let's go back. A, B, C, D. So I'm not going to create a story. I'm just going to draw the diagram, put some measurements on, and then the instruction says 1, find the length. Writing it too big. Find the length of X. Find the length of X. That's all I'm saying. Any suggestions from anybody? Apart from I don't know and I cannot do it, sir. Oh, wait, no, guys, talk to me, no, man.
Sure, era times width.
Run that by me again.
Era times width.
Area times width. You are correct, you know. You
I
are
am.
absolutely correct. Of course you are.
Just saying.
Well, hold on. What is the area times width? Or area divided by width?
I said times, sir, but I guess it's divide.
Yeah, I would be times. But still, what I want from you is I want you and everybody else to get out of the habit of guessing. I want you to be able to write down stuff and let the writing lead you to the answer. So how would we start it? What is the method that I've explained to you? How do we start every question?
Down the formula.
Very good. Write down the formula. Practice it, guys. It's going to be your saving grace. Every time you get a question, start by writing down your formula. You have two advantages for this. Number one, you will always know what to do next. And two, it is a way of subconsciously practicing to get the formula in your cerebrum, in your brain. The more you write the formula, is the more it will stick. So what kind of shape is this?
A rectangle.
Correct. It's a rectangle. It couldn't be a square. You know why it couldn't be a square? Not only because of how it looks, but the mere fact that they ask you for the mere fact that they ask you for X, if it was the same, they wouldn't ask you for it. Why would they ask you for something that is already obvious? So if they ask you to find something, it means that it's different. Even if it's just a couple centimeters different, it is different. So we start out by saying A is equal to length multiplied by width. Not true? What we're going to do next, ladies and gentlemen, is we're going to place the numbers or the dimensions as written on the diagram under
So is it
its
multiply or
respective letters.
divide?
If what was multiplied or divided.
Pardon?
No, I'm saying if what was multiplied or divided.
Because at first you said that it should be divided.
Right, we're gonna get there. You're gonna see why we say it's divided.
Okay.
So I'm walking you through how I got to the point where it's divided. So we're gonna take the respective numbers that are written on the diagram and place them under the respective letter. Where would I put the 14.3? Under which one of those letters would I put the 14.3?
The W, sir.
The W, all right. You want to call the W? No problem, no problem. Not a problem. So I'm going to put the 14.3 right underneath the W. What would I put underneath L?
Nothing, sir.
But we are fine.
So you have to write back.
So we can write back L if we want, or we can just do it and put X. Not true? But Shawan, you're still right, you know. You're still right. We would not put anything, but we need to put a letter there to show the marker or the examiner that this is what we're finding. So if you want to write back L or you want to write X, that's up to you, yeah? Okay, you can just leave it blank like that. You can even put a question mark too. So 14.3. And then what would I put underneath A?
110
centimeters.
110. Now watch how the guesswork is exempted from the math. What's the opposite of multiply?
Division.
Very good. That's how we know to divide. So 110 divided by 14.3, and that will give us the value of X. Therefore, X is equal to?
I got 7.6.
Somebody confirm that, please. 7.6?
9.
Beautiful. So that is how we know it's divided, guys. Pardon me?
7.6.
All right, 7.6. So that is how we know it's divided, guys. It's not a boy, I wonder if we articulate ourselves on paper. So you have a formula, and based on the numbers that are given to you on the diagram or in the question, because sometimes they will write the question worded, based on the information that is given to you in the question or on the diagram, you place the respective numerical values underneath the respective letters and let the formula tell you what to do. So if there was a plus sign between the L and the W, we would end up subtracting. If there was a subtraction sign between the L and the W, we'll end up adding. If there was a division sign between the L and the W, we'll end up multiplying. And if there was a multiplication sign like what we have here, then we'll end up dividing. Is everybody on track?
Yes, sir.
All right, solid. All right, give me a time check. What time are we looking at now? So I think there's another question that I would love to go through.
8:23. 8:23.
We have 7 minutes, so I'm going to try squeezing the question here. All right? Work with me. So this was a past CXE question. I literally memorized it in my head, because I think it was a really good question to test the students' ability to think. Hold on. I'm trying to make the app do a perfect drawing for me. Hold on, guys. Give me a sec. Not doing it. Hold on.
Is that you, Jerome?
Somebody's mic is unmuted, please. Remember, the class is being recorded. No, say it now. Work. Draw a circle instead. Go try it again. No, say it now. Work. It's not working, guys. It's not going to give me what I want. So I'm going to draw it by hand then. So boom, 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 boom. Like here, like this, like that, and like that. Right, it now give me the diagram I want. But all right, here we go, guys. So I'm gonna put some dimensions on this. We might go over the class time, but you know we go. Sometimes we're gonna end early, like a little bit early. Sometimes we're going to go over, but we want to get this across first before we get out of here. Okay, so I'm gonna call this side up here so 9.3. Centimeter. I'm gonna call this side over here 5.2 centimeter. All right, it's a little bit too big. I'm gonna call this little short side down here, so 4.7 centimeter. Please make sure you draw your diagram better than mine, please. I'm not a very good artist, especially on this. You know, when it becomes technological, I'm getting used to this thing here. All right, I'm going to call this side 2.7 centimeter. The reason I'm using so many decimals, guys, is that a lot of the times when I use whole numbers and then I give you an assessment with decimals, people just make the question look harder. So I practice all my examples in class. I try to mix them with a lot of decimals. So I try to do the harder questions in class and then make it easier on assessments. That's just my way of doing it. All right, and then I'm gonna call down here. So for nah, I'm gonna call down here. So what should I call it? What should I call it? Let's call it
7.6.
Yeah, we can let's just call it that. 7.6. Right. It really doesn't matter, but I'm trying to make the question as realistic as possible. All right. All right, beautiful. So here is the question now. So the question here says, I hope nobody has to go in. Right. So one, they can ask you to find black. Okay. One, find the area of, I'm going to call it the floor. Because like I explained to you earlier, guys, a lot of the times when you get exam or assessment question, a story is created around the question. Now, I didn't create a story around this one, but I could. So I could have said to you here that the diagram, I could have said to you here that the diagram above or below represents the drawing of the floor of a building. All right, so it represents the drawing or the architectural design of the floor of a building with dimensions 9.3, 5.2, 4.7, 2.7, and 7.6. And then I could say to you, one, find the area of the floor. And I could go further and say, two, find the perimeter of the floor. All right. Now, for the area of the floor, question to you guys. The diagram that you're looking at, does it have a name? Is it a shape? Like you can look at a circle and say, oh, that's a circle, that's a rectangle, that's a square, that's a trapezium, that's a parallelogram. Does this particular shape have a name? Does it have a name, guys?
Yeah, it is two rectangle, what do you call it?
So it doesn't have a name, but I hear you a while ago you said something that it's a rectangle. It's two rectangles, not two.
That's it.
All right. So for those who don't see the two rectangles, then if we were to take some broken lines, let me just zoom up for you. If we were to take some broken lines and go boom and chop it right as so, you'd realize that it's basically two rectangles that is mounted on top of each other. So one rectangle is mounted on the edge of the other rectangle. But if you don't draw that broken line, you won't see it. And that's not the only way that's not the only direction you can draw the broken line. I could draw the broken line in this direction as well. And I could create three rectangles instead. But where you have to draw more construction lines, it's going to be more challenging. So always choose the road where you draw less construction lines. So I'm going to draw it this way instead. All right. Any suggestions? Throw some suggestions out there, guys. How do you approach a question like this?
So, just something that I noticed, right? Because if it's two rectangles on each other, and where you have 4.7 centimeter, then down the bottom should be 4.7 as well.
Well, where I have the 4.7, I started here and I ended here.
Okay.
So we still have that little piece that we left over.
Okay.
Got you. All right, so I don't have the full top. All right, any suggestions, guys?
I want to divide it, but then when I look on it, into the
You know, work
question.
one of the rectangle first.
You'd work one of the rectangle first, not you?
I don't
Yeah,
know
so
that.
what you do is, I go ahead, I'm listening.
That's what I was asking.
No, I tell you, if you tell me what you would have doing,
Oh,
and then
yeah.
I'll agree or
That's
disagree.
what comes to my mind. I would work
So
one of
what
the
comes to your mind is to
rectangle
do what? When you say work out, when you say work out, be more specific. When you say work out, you mean find the area?
first. Find the area of one of the one of the rectangle.
And then what you gonna do with the other one?
Find it and then
And then beautiful, beautiful, beautiful. But you're not saying it with no conviction. So you go find the area of the top triangle, not the top rectangle, pardon me.
Yeah.
Then you go find the area for the bottom rectangle and
Yeah,
then add both areas together. No, so that's the plan,
Yeah.
right? So
Yes,
we go
sir.
call with top rectangle
Sir,
A. Yes, talk to me.
seeing that they're both rectangles, then that means length for each side will be the same.
Not
For
necessarily, because you can have a small rectangle mounted on a big rectangle.
yeah, that I know, but the size, for example, the bottom one B, right? That is a rectangle. The length would be the same. So the 2.7 centimeter, it should the other side, the length on the other side, the left
Oh,
hand
I get what you're
should
saying.
be
I get what
also
you're saying.
7. The
Oh,
top
so you're saying
part
that
is
over
saying,
here is 2.7.
yes, the top part is saying 4.7 centimeter and the bottom is also saying 7.6 centimeter. What I did, I minus the 4.7 from the 7.6 to get the small part.
The
Yes,
little
about
piece,
the
the little
right.
piece of chopped in there, so not true.
Yeah, to get the
Beautiful.
7.6 centimeter.
Let me draw my arrow. Let me draw my arrow as you talk. I know why you lose me. Hold on, where did my diagram go? Oh my lord. Guys, I lost my diagram. Oh my gosh, I lost my diagram. wait, where my diagram gone? Guys, I lost my diagram. This is the second time it happened to
I
me.
think I took the screenshot. Hold on. I don't remember. Let me double check.
Me no wait. I have to go sketch it over. This is the second time this app
No, I
did that to
didn't
me.
get the screenshot.
Can't believe it. I hate this. See it here, man. It's good.
Yes.
We're good. Okay, right. So let me just draw one little arrow here. Boom. So you're seeing that little piece in there, and I hope everybody's following her analyzation.
So it would be 2.9 for that little part.
All right, so let us write that information down because that is crucial later on. So later on we're gonna use it. So hold on, we're gonna say, all right, boom. The little piece right in there so is going to be 7.6 minus 4.7.
7.
What you get?
2.9.
All right, so we have that information. We might need it later, so let us see what happens. Miss Cherry, thank you very much for that. You wanted to add more?
Is Danica talking?
Danica, you wanted to add more? Are you good?
For the top one, the bigger rectangle on the left side is going to be the same as the length.
5.2.
Yeah. For the bottom part, seeing that it would be 9.3 because
The part you're talking? Is that part you're talking?
is
that part you're trying to find?
The whole part, me did say would have been 9.3, but seeing that, me just realized the part I cut off there, so no, me don't know if you do.
No, but you're there for your week. I remember, you just found this little piece where the arrow is pointing from. This piece right here, so you just found it, to be 2.9, right? And the whole top piece is 9.3.
So I'm going to divide that by 2.
No, you do the same thing that you just did earlier. Remember, you just said that the bottom part is 7.6.
Yeah, but
And the
no,
top part is what?
no thing is there, no farmer measurement, no the day. So
Yeah, but remember say, are you just find a piece here, no, Danica? You just said it's a 2.9, you know.
oh yeah.
So the top part
You
of
keep the label
9.3, and you
there.
just find the
So you're
2.9.
going to minus the
So you have
9.3 from
9.3
the 2.9.
for the
A
2.9 what you
positive
just find.
label. Yeah.
Yeah, how much you get now?
Me never calculate that, so I'm gonna do
Yeah,
it
man,
now.
match it up, no, man, match it up. Because we're there for staying.
Minus 2.9, 6.4.
All right, so you see those little calculation, guys, are going to be crucial for part B. All right, thank you very much, Danica. I really appreciate that because that's something that a lot of students. I'm coming to you, Miss Sherry. Are you we are going to come to next month? We're not forget about you.
No, it's not Miss Sherry.
Me.
Who said that?
Stacy.
Stacy, hold on. Come, know you're a bright girl, so hold on.
I don't know one thing to just do a while ago.
No, we were just calibrating how to find those little missing sides because we didn't get all the sides on the diagram. The only thing that we got Stacy, is the 9.3, the 5.2, the 4.7, the 2.7, and the 7.6.
Okay.
So Danica was using the properties that we discussed earlier to say, okay, if this side over here says 2.7, then it means that side are 2.7.
Okay.
And then a little empty piece right in here, so, right, where we have, she's
2.9.
suggesting that since the bottom part is 7.6, and a little short piece up top that says 4.7,
minus
she
it.
subtracted them to find a little piece inside here, so.
Okay, I got you.
Then we didn't find this little piece right here that I'm coloring now, right here, so we don't know what that is, and that's going to be crucial later on. So she also analyzed that since the top part is 9.3, and she just calculated that 2.9, she subtracted them to get that little 6.4 there.
Okay.
So all of those are going to be needed later on. Okay?
Okay. All right.
Miss Cherry, back to you. So you had made a suggestion that we're going to find the area of the top, then the area of the bottom, and then suggest and add them. That's what you said, right? Right, Miss Cherry?
Yes, sir. Yes, sir.
All right. So come now, work with me now, man. You make the suggestion. So area of the top. Where you go find the area of the top? What's the formula for the area of the top?
The formula.
You say it's a rectangle, you know, so talk to me.
The 9.3.
More want a formula, Miss Cherry. Remember, so we talked about that already.
Yeah.
You know? Always start with a formula. Area is equal to
9.3.
Formula. Length times width.
Length times width.
Ready now. Give me the numbers then now. Oh, you said 9.3. Sorry. 9.3. Times
5.2.
Excellent. Punch that in your machine and give me your answer. Or can somebody help her?
My machine is malfunctioning.
All right. Somebody help her now, please.
48.36.
48.36, so 48.4. Good. Squared centimeters. Miss Cherry, now, just direct us, because we know you don't have the machine. So direct us now, so we're going to find the other area now. We're going to call it A2. So we're going to call this A1 up here. We're going to call this B1. So we're going to say then that, so B now is equal to, again, is it length times width again?
Yes, sir.
So B now is equal to, what is the length now, Miss Cherry?
Are you gonna add the little?
No, man, we don't need the little pieces have nothing to do with the area, man.
So it's 4.7 cm.
No, sir.
No, it would be the 7.6 times the 2.7.
Oh, yes.
7.6 times the 2. Because we look at the length and width, the 4.7 is just
a
portion of the length.
Yes. Got you.
All right. Work with that for me now. What is that answer?
20.5.
I didn't hear that.
20.5.
So 20.5 square centimeters. So now you have the two measurements down now, Miss Sherry. The two measurements then now. So therefore then, to find the final area then, the final area is going to be equal to, sorry for making it so chopped up, guys, but you know everything already. So it's going to be 48.4 plus 20.5. And that sounds like 68.9. Confirm.
Yes, sir.
Is it?
Yes, sir.
68.9. Beautiful. I guess so we never get involved. I didn't even get it. I was just there as the shepherd. Because Miss Cherry started off the suggestion of finding the ear of the top and the bottom and adding them, and then Danica chip in by finding the little missing sides that we are now going to need. We're going to need that part now, you know. So without Danica's interjection earlier into finding those sides, we couldn't find the perimeter because perimeter means distance around, correct?
Yes, sir.
So we're going to add all the sides. So that's going to be 9.3. Let's start with me now. Write us over there. 9.3. All right, so because I'm running out of space, guys, and I won't be able to write it on the screen. So work with me. Just type it in on your devices as we go along. 9.3 plus 5.2, that's the one to the side, plus 4.7 plus 2.7 plus 7.6 plus 2.7 again plus, thank God for Danica. She just calculated the 6.4 because we never know what it was, you know. So because of that ingenuity there, we were able to calculate that 6.4. So that's plus 6.4 plus the last one, which is 5.2. How much you got?
Sir, are you sure it's 40.4?
I'm not hearing the answers clearly. Talk to me.
Are you sure it's 6.4?
Yeah, hit me the answer, no, because it should
Are
be.
you telling me 9.3 minus 2.9? Are you say 6.4?
Yeah. Oh, you give us the 2.9 when we were adding, and then you give us the 6.4.
Yes, so the 2.9 was calculated because you subtracted 4.7 from 7.6.
I know, but I'm saying when you were telling us to add up the numbers for you gave us the two numbers, right? The 2.9 and also the 6.4, right?
Oh no, the 2.9 wouldn't be involved because the 2.9 is in between, it's not around the edge.
Oh, okay.
So we wouldn't add the 2.9. The 2.9 is not on the edge of the diagram, it's just in between the diagram.
Okay, so I got 43.8.
How much you got?
43.8.
Can somebody confirm that?
Yes, sir.
Yes, sir.
Okay, 43.8 centimeter. And that is that question. That is how we deal with a question like that. So that was good. That was good. Most of the question was done by you. I was just there as the shepherd to allow you not to fall into a pothole. But I hope you guys get an understanding of the thought process that goes behind this. But remember, our number one rule, guys, not just this class, but every class going forward. Once you're working a question, ladies and gentlemen, you need to write down your formula. If you're going to find area of whatever shape, you write area equals that times that or that plus that. Then you put the numbers under their respective position, and then the formula will tell you what to do. Okay? We will pick up on this topic next week, Thursday. Monday, we're going to start algebra. So pick up on this topic next week, Thursday. And we're going to be moving into triangles then. All right. So that's pretty much it, ladies and gentlemen. Thank you. We've gone over a little usual time, but I think it was a good class, in my opinion. The class is being recorded and it will be posted sometime over the weekend. So if you feel like you need to do a run through again, you know where to find the videos. Okay.